Okay, so this is an example question from the Big Island of Hawaii lab. It uses the geovisualization, but a lot of the methods in finding the answer are done on paper. So the question is going to go something like this. In a transect of dew points from the summit of Mauna Kea and walking north in the geovisualization, what 500 meters of elevation change had the least change, or lowest gradient, in dew point change? Also, what is that gradient measured in degrees Fahrenheit per 100 meters? So there's a lot of information that we need to take in. The best way to do this is to open the geovisualization, go to the summit of Mauna Kea, and just begin walking north or down slope and recording the dew points every 500 meters. So this is a little bit of what that's going to look like. If you imagine that this is the slope of Mauna Kea, for example, this is the peak. So you're going to drop off your avatar up here and record the elevation and the dew point. And then when it says every 500 meters, that just means every even numbered 500 meters, like 0, 500 meters, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, and 4,000. And then the summit is at 4,175. So you're going to get dropped off at the summit, which is 4,175 meters. You're going to go down to 4,000, then 3,500, then 3,000, 2,500, 2,000, 1,500, 1,000, 500, and then sea level, so 0. So all the way down. So you're going to start here, and this direction is north. So you're going to start at the top, turn your avatar to the north, and begin walking downhill. And when you get to these elevations, stop, record the elevation, and record the dew point temperature, which is measured in degrees Fahrenheit. So the best way to record this information is in a chart. So we need to record our elevation. So elevation, we need to record our dew point, which is in degrees Fahrenheit, and elevation is in meters. And let's start off by just going to each of these locations and recording the elevation and the dew point, and then we can begin to answer the rest of the question. So you're going to get dropped off at the summit, where your elevation is 4,175, and your dew point is 12. Then you walk down slope a little bit, get to 4,000 meters, and your dew point is also 12 degrees. Then 3,500 meters, your dew point is 20 degrees. 3,000, your dew point is 28 degrees. 2,500, 2,000, 1,500, 1,000, 500, and 0. So at 2,500, it's 36 degrees. At 2,000, it's 42 degrees. 1,500 is 50 degrees. 1,000 is 58 degrees. 500 is 63 degrees, and 0, you can't actually get to 0 because it's in the ocean, but the closest elevation is at 35 meters, but just pretend that that's 0 and it's going to work out just fine. So at 35 meters, or at 0, the dew point temperature is 66 degrees. So now let's begin to use this information to answer the question. So let's split these up a little bit. Now, let's start answering the question. So, in a transect of dew points from the summit of Mauna Kea and walking north, what 500 meters of elevation change had the least change in terms of gradient? So the lowest gradient in dew point change. So all that is just the change in dew point temperature per change in elevation. So our change, let's make this our change in degrees Fahrenheit. So the change in dew point temperature from 4175 meters to 4,000 meters is 0. Our change from 4,000 to 3,500 is 8 degrees. Our change here is 8 degrees. Our change here is 8 degrees. Our change here is 8 degrees. Our change here, 8 degrees, 8 degrees, 5 degrees, and 3 degrees. And our change in elevation is right here, 175 meters. And everywhere else it's just 500. 500, because we're going by 500 meter intervals. 500, 500, 500, 500. So what we're saying here is that we've changed 0 degrees every 175 meters. Right here, we've changed 8 degrees every 500 meters, 8 degrees every 500 meters, 5 degrees every 500 meters, and 3 degrees every 500 meters. So now we need to know our gradient in degrees Fahrenheit per 100 meters. So our change here is 0 degrees every 175 meters. So that's just 0 degrees. So that's 0 degrees per 100 meters. Here, it's 8 degrees every 500 meters, which if we do a little bit of cross multiplication, 8 over 500, or here over here, 8 degrees Fahrenheit over 500 meters equals x degrees Fahrenheit over 100 meters. You can just do some cross multiplication. So 8 times 100 equals 500 times x. You divide it out, you see that x equals 1.6 per 100 meters. Another way to do it is just that you know that 100 meters is 1/5, or 5 times less than 500. So you can just divide 8 by 5, which equals 1.6. And this is the same all the way across here. So all these gradients are all 1.6 degrees every 100 meters. These last two are different though. So 5 degrees every 500 meters, that's 1 degree every 100 meters. And over here, 3 degrees every 500 meters is 0.6 degrees per 100 meters. So now, to answer the first question, What 500 meters of elevation change had the least amount of change, or the lowest gradient in dew point? Well, from the summit to 4,000 meters is 0 degrees, but that's not a 500 meter increment. That's a 175 meter increment. So we need to check the rest of these where we went down by 500 meters. These are all 1.6 degrees per 100 meters, all right? This one is 1 degree every 100 meters, which is less than that. But right down here, between 0 and 500 meters, our gradient is 0.6 degrees Fahrenheit of change per 100 meters. So that is our lowest gradient. So the smallest change per 500 meters is 3 degrees Fahrenheit, and that gradient is 0.6 degrees Fahrenheit per 100 meters. So between between 0 meters and 500 meters, our change in temperature, or our delta T, our change in temperature, equals 3 degrees Fahrenheit per 500 meters. So that's our least change. So right here between 0 to 500 meters. And our gradient measured in degrees per 100 meters is 0.6 degrees Fahrenheit per 100 meters, which occurred between sea level and 500 meters. And this happens because in the lowest parts of the atmosphere, near the ocean surface, this is at the edge of the island, it's been picking up water vapor over a long stretch of the ocean surface. So it's basically at equilibrium, and it's absorbed all the water vapor that it can. So the dew point gradient is at its lowest.